Hello, I am Danielle Moriarty, and my partner is Scott Pham. We are Group 53, and for our CS147 project this quarter, we will be creating SproutSense, a smart plant monitoring device. Our motivation for this project are the common challenges that plant owners face. One of these challenges are inconsistent or incorrect watering schedules, neglect of plants, and inadequate environmental conditions such as temperature, light, and humidity. The consequences of these issues are plant death, which can lead to financial loss because plants are expensive and supplies cost money. Also, the obvious, which is your plants are dying. Our project also goes to address the knowledge gap that plant owners have when taking care of their plant. With all that in mind, our device will hopefully inform users about their plant needs in real time and educate them on how to take care of their future plants. The benefits of this monitoring device is that it will prevent plant deaths and also promote a healthier, more sustainable plant growth. At its core, we aim to create a plant monitoring device that will sense and analyze the ambient environment and moistures of soil and collect data on the humidity, temperature, light, and moisture of the soil. With this data, we will notify the owner that it is time to water their plants. This will ensure that plant owners will maintain ideal conditions for their plants' survival.
Our plant monitor will employ a sensor mobile app cloud architecture, where the sensors such as the humidity, temperature, and light sensors will collect real-time data from the plant and its surrounding environment. For communication, Bluetooth Low Energy will transmit the data from our monitor to nearby devices like a mobile phone, and the mobile phone will use Wi-Fi to transmit its data to cloud services and store and process data. Then a mobile app or web app will provide a user interface using the data from our cloud services for our end user to interact and get notifications of when to water their plants. For our development process, we've devised 5 milestones that we aim to reach in order to implement our device. The first being to finalize our component list and flesh out our communication protocols to properly build our device. Then our next milestone is to build and configure our circuit. We'll configure the sensors for moisture, temperature, light, and humidity, and implement ways that our device can communicate with other test devices. Then we'll ensure data transmission by establishing BLE connectivity with our sensors and enable data transmission to the cloud. Our fourth milestone is to set up our cloud infrastructure, which includes storing, processing, and analyzing our data from our sensors, as well as build analytics and generate plant care notifications. Our last milestone is to develop our web application, which allows users to monitor their plants real time and see their data visualized, as well as creating a user-friendly interface for tracking plant conditions and receiving notifications. By the end of this project, our expected outcomes are a functional plant monitor that collects our important data such as soil moisture, air humidity, temperature, and light levels, as well as notifying our users when to water their plants. We also aim to provide analytics on ambient environmental conditions to better notify our users on the conditions that their plants are in. Our deliverable for the class will hopefully be a demonstration video that showcases our device in action live and receiving live notifications that is sent to a mobile device.